This game is really good practice for you, and you are going to have to, on your worksheet today, go from binary to hexadecimal. So just a quick little review of that. Whatever number you have, break it into chunks of 4, like yesterday or Friday, we ended on this one. So starting on the right, we did a group of 4, and so on. Then I figure out the decimal value of that binary, and then make sure I translate it to hexadecimal if I need to. Okay, so that's how we go from binary to hexadecimal. Chunk it into 4s, and then your digits are 1, 1, 2, 4, 8. So this one is a little tricky for some students. How do I chunk that?
4 and 1.
Okay, good. So remember, we always start on the right. So start counting from here. So this is going to be 1 as a digit, and then 0, 1, 0, 1 as a digit, like that. Okay, so just remember where you start chunking stuff. And then I have my 4 and my 1 turned on, so this is 5. This one, everything else is zeros, so it's just going to be 1. So again, difficult part for students here is, does that look like a hexadecimal number? It really doesn't. It looks like a decimal number, right? So you have to pay attention to, if I say you're converting from binary to hexadecimal or hexadecimal to decimal, pay attention to it, because it can look like a decimal number and be a hexadecimal number, but the value is very different. Okay, great. So we played that game. The next conversion, so open up your notes if you were typing them in, or if you were writing it on paper, get your notes out. The next conversion is going from hexadecimal to decimal. Okay, so I have really stressed to you guys the way that our decimal system is set up. Like when I want to add a new digit, I multiply by 10 because we have 10 possible symbols. And in binary, when I want to add another digit, I multiply by 2 because we have 2 possible digits. Hexadecimal has 16, starting with 0 through 9 and then A through F. 16 possible digits here. Okay, so that means anytime we want to add a new digit, what do you think we multiply by? 16. Okay, so this is our ones place or our units place, always, no matter the numbering systems, always our ones place. Then to get the value of the next digit, I multiply by 16. So 1 times 16 is 16. This is my 16th place. To get the next digit, I take 16 times 16, which makes this my 256 digit. Okay? That's the highest we're going to go. We could keep adding digits. We're just not going to go that high with the math in this class. So think about the number 57, our decimal number 57. What does the 5 tell me?
There's 5 tens in 10th place.
I have 5 tens. Okay? That's the exact same way hexadecimal numbers work. But instead of the tens place, it's my 16s. So right here, this is E, which is equivalent to 14. So this is telling me I have 14 16s. That's what the E in that second digit means. Okay? So to go from hexadecimal to decimal, we're going to remember the way that this system's set up. So what's in my ones place? 6. So I'm going to take 1 or 6 times 1. Okay? What's in my 16's place?
14.
E or 14. So I'm going to take 14 times 16. What's in my 256 place? 2. So I'm going to take 2 times 256. So I multiply each of those by the value of the digit, and then I add them together. And that tells me the decimal equivalent of my hexadecimal value. That is the same pattern that you're going to use anytime you convert from hexadecimal to decimal. You figure out what's in your ones place, multiply by 1, figure out what's in your 16th place, multiply by 16, figure out what's in your 256 place, multiply by 256. Does that make sense? Same pattern every time. So our decimal equivalent of the hexadecimal 2E6 is 742. Okay?
Miss Bensley, do you understand this stuff?
Yes.
Where'd you get the 14 from?
The 14 right here is because I have an E. So I have to look over here and see that E is equivalent to 14.
Where'd you get the 6?
This is my ones place. So I take 1 times 6. Okay. This is my 16s place. So I take whatever value is here by 16.
16.
And this is my 256 place. So I multiply that by 256. So it's always times 1 times 16 times 256.
So 6
These
times-
numbers change based on what my hexadecimal number is.
So what place do you use?
For our class, we'll do 2 or 3 digits. That's the highest we'll go.
So 6 times.
And I am also okay if you guys use your calculator for the hexadecimal calculations. Okay. All right. So let's practice it with a second value. Okay, so here is F2B. F2B. So with your neighbor, see if you can figure out what values in our ones place to multiply by 1, what values in our 16s place to multiply by 16, and what values in our 256 place. And when you think you have the answer, let me know so I can come and check it. Yeah, you can use a calculator. Do this now. Do this now. Right, so show me. Show me.
Did we add them all up?
Yes, you just add them all up. Yes. Well, I know the rest of you. Very good. Very good. Very good. Very good. Very good. Very good. Very Oh, hold on, hold on. This is your 16th place. This is the 256. All right, so I think people are kind of figuring it out. What value is in my ones place? 11, right? Because it's a B, which lines up with 11. So I take 11 times 1. What value is in my 16s place? 2. So I take 2 times 16. What value is in my 256 place? 15. It's an F, so it's 15. So I take 15 times 256. What do I do next? Addition. Add them all together. So I take 11 plus 32 plus 3,840. The hexadecimal value F2B is equivalent to the decimal value 3,883. Okay? So multiplication and addition. Let's do one more. What's up?
Yes, we need another one.
You sure? You got it?
Okay, man.
Okay. All right, let's do one more.
Oh my God. Oh my.
111. It's the exact same process. You just have to figure out what the values are. What's the ones place? What's the 16s place? What's the 256 place?
Got it.
Very good. Very good. Very good. Check it out.
Buddy. So, that one, the first one,
I did it right in my head.
Okay, pretty much I think you guys are getting this. What's in my ones place? What's in my 16's place? 1, right? 1 is in my 16's. Oh, you guys were giving me the total. Okay. So yeah, 1 times 16 is 16. And then what value is in my 256 place?
256.
Right? 1. So I take 1 times 256 and it gives me 256. Add them together. 273. Okay? All right. So that's going from hexadecimal to decimal. We multiply and we add. So what do you guys think if I go from hexadecimal to decimal by multiplying and adding? How do you think I reverse that? How do I go from decimal to hexadecimal? Divide and subtract. Perfect. So this is our last conversion. The decimal number. Oh, I'm sorry. Hold on. Let me say something about this one. Again, the hard parts about this for students. Does that look like a hexadecimal number? It could be binary. It could be decimal. It could be hexadecimal. So pay attention to the labels. Make sure you understand that when I have a 1 right here, it means I have 116, not 110 and not 12, right? Okay, good. So now I have the decimal 205, and I want to figure out the hexadecimal equivalent. Okay, so anything that is less than 255, I only need 2 hexadecimal digits. If it's more than that, I'm going to start by dividing by 256. But since I'm less than that, I start by dividing 205 by 16. Okay? Here's an issue that students often come across. If I type in to my calculator 205 divided by 16, this is the answer. It's 12.8125. When we're doing these conversions, that decimal doesn't matter. We're going to do something called truncate, which just means you completely delete it. I don't look at it in round. I don't even act like it's there. All I want is the integer in front of my decimal point. Okay, so right now I've done 256 divided by 16. This is the only value I'm concerned with. That, since I just divided by 16, is going to go in my 16's place. So my 16's place is going to be C, because the answer was 12, which lines up with C, right? Okay, now I want to know what's left. After I have had 12 16s in there, what value is left of my 205? This is where mod comes in, because I need to know what's left over. So if I do 205 mod 16, which you guys can type into your Google address bar, you can do 205% sign 16. You can type in 205 mod MOD 16, and it's going to give you the result. I haven't been able to look on the TI-85 calculator enough to see if it's a function on there. I'm sure it is. I just don't know how to get it. But I'm going to do 205 mod 16. Okay, and it is going to tell me that the result is 13. So that means when I have taken out 12 16s, only 13 is left. Okay, so what value lines up with 13? D. So I know that my hexadecimal equivalent of the decimal 205 is CD. Okay? So C goes first because that's where I divided by 16. So that's my 16's place. And then my remainder here. If I had a number that was above the 256, then instead of dividing by 16 first, I would divide by 256. I divide by 256 and figure out my mod. I divide by 16 and figure out my mod. And then it gives me my ones place. Okay? So let's do another one. Number 73. What is 73 in hexadecimal? So is that number greater than 255 or less than? Less than. So that lets us know we are going to divide by 16 first. Okay. 73 divided by 16 gives me 4 point something, something, something. But I'm going to truncate that. Think about like the trunk of a tree. You know, when you have a tree and you cut it down, you're left with just the trunk. That's what my brain thinks of when I think of truncating a decimal. It means it's gone. All I have is the main number. Okay. Okay, so then I know I'm going to have a 4 in my 16s place. I have to figure out what value's left over. So I'm going to do 73 mod 16, which is 9. So that's going to be my ones place. So the decimal 73 is the equivalent of the hexadecimal for 9.
Wait, what's the point of 4?
This tells me how many 16s I have. So this 4 goes in my 16s place. Okay. Okay. You ready? Let's do one more. 182. Is that number greater than 256? It is not. Okay, so we are going to start dividing with what value? 16. Okay? You go ahead and do it. See if you can figure out what the decimal equivalent is. And I'll come around and check. So that's right. That's your 16. What's left? What's my remaining? You can just have it in order. Very good. Oh wait, hold on. Which one did you have circled? It's the opposite. You're super close, but remember we can't have 2 digits. Okay. Great. Good. All right. Good.
What do you say?
All right. So I took 182 divided by 16, which gave me 11. This is one of the common errors that students get. If you get an 11, does that fit in a digit?
Yeah, no.
It doesn't. So that's where our letters come into play. So 11 is B, right? So that gives us B. And then the remainder, 182 mod 16 is 6. So our answer is B6. Okay? All right. You guys are going to go to Google Classroom and open up the 1.4.3.
Yes.
Thank you. Okay. This is going to have you do all 3 conversions we've talked about. You're going to go from binary to hexadecimal, which remember you chunk into 4s and do 1, 2, 4, 8 on each one. You're going to go from hexadecimal to decimal, where we multiply and add. And you're going to go from decimal to hexadecimal, where we divide and subtract. All 3 of them. Please make sure when you type it in that you're using capital letters. Okay. And don't include any extra spacing. Okay. The code is October with a capital O. October. Yes. Would you like to? When you are done with it, Go ahead and go back to the alien game and see how high you can get your score. No. You can use your whiteboard.
Can I make a flippy out of my whiteboard?
Yeah, you can use your whiteboard. You can also use the calculator to do your like multiplication and subtraction and all that type of stuff. That's like the one with the aliens falling down. 1, 2, 4, 8, 1, 2, 4, 8. So this 1, 2, 4, 8. What's the total value of that?
What, you only get a better?
Hey, see that? Well, I don't know.
You not give me something?
No.
So what? We're going to go that way. You know A is 10. A. So write A10 and then write the rest of it. Your 12. 1, 2, 4, 8, starting on the right. 1, 2, 4, 8. Or you know, like our ones place times hundreds, thousands. Builds the same.
And it goes. And then do I need to do this where 13 is in front and this third?
This number goes on the right side, this number goes on the left side.
So do the letters start, the letters start with no spaces? So it's just this one and this one. So is this correct? Catholic? Okay, I'm actually not
Oh, wait, it's 13.
Take some filters here.
So you look at this side, and you look at that, look at that side, and you look at that side. This left number will be on the left, this right. Hey, you figure your own. You figure yours out.
Why does it need to be? Yeah, buddy.
Yes. Capital S.
Whoa.
I will be right there. Are you allowed to what? Yes, you can look at your notes.
1,000 is wrong.
Yes. You guys can use your calculator. Yes.
But why would it not have a letter when this one goes?
Because to get to a letter, you need to be in and none of those bits are those.
I don't get have.
Yes.
How are they not in the side?
Because they don't total about it. I mean, it's just not. The juice turned on and then that on that straight. Or what? Yes.
Yeah.
Wait, what? Yeah, I would say probably. No, you're okay. You need to use the calculator. You can use your notes. Oh my goodness. Your work done.
Oh my God.
well, then show me that you can sit there and get your work done.
It is 10, right? Yeah, but I did it like, so I knew that all
So
these.
if I do 0, 0, 1, 1, what's the total value of that? 3. Okay. And if I do 1, 1, 1, 1, what's the value of that? Okay, so what does that line up with?
Oh, I think you're right.
Okay, so figure out the decimal value of each set of 4, and that's your answer.